what data is at risk due to that activity, how much sensitive is that data involved over here, is it the production data, is it the customer data which is at risk over there, and the associated exposures and misconfiguration with the resource. So let's say if someone is doing a database query, so it will identify the exposures related to the database over there. If there is a data residency issue, which is breaching your compliance posture of your GDPR or RBI regulation or SEBI regulation, then it will go through and understand that particular exposure, and it will pull the logs from different sources and correlate that logs. Now, for the same identity, it could be doing database activity. The same identity could be doing activities on the AWS, on your Google Drive, OneDrive. So the agent pull all those contexts from different sources and then correlates, and then comes the decision engine, which then identify what would be the right fix for this particular scenario. Is it something which is leading to an attack, or is it just a compliance breach? So each of the issues are handled in a different way over here. And then comes the action layer, like based on the risk involved. Like if it is a very high critical risk, right, the action would be defined in a similar way. So for example, let's say we found sensitive data in place where it should not be, right? So the difference between whether I should be redacting the sensitive content over there, or I should be archiving or deleting the file completely, right? So that depends on totally on the type of incident that has happened, right? Or if there is a misconfiguration which is associated with a particular asset, right? So in that case, the agent will recommend to fix the misconfiguration in a way it do not impact your production workload. So it will not just suggest the fix, but it will identify the uh, associated vulnerabilities with it, and like what impact it could have on a production. So let's take an example. There's a S3 bucket which is publicly accessible, right? Now, if you just directly make it private, it could be having impact on your production application which are working. So the agent is smart enough to look at those edge cases which could disrupt your production and suggest you accordingly over there. So we'll have a look at quick demo of how this is going to work. So this is an example, like I'll give you a walkthrough of the exposures over here. So exposures is something that matters surface as part of your risk involving sensitive data. Now it could be sensitive data stored outside regulated region, or presence of a PII data where it should not be. Okay, and uh, that's how there are multiple exposures surface over here, which could belong to stale data category, sensitive findings. So we'll take one of the issue, which is the data residency issue, one of the most complex issue. We'll walk through how this matters agent is able to fix this end to end. So in this particular scenario, PCI data is found outside regulated region, that is Poland. Now, it could be breaching multiple compliance regulation related to GDPR and other regulation. So we'll first understand what is the first we'll start with the remediation to understand the issue, what is the depth of this issue, and so if the agent comes up with the overall thing that it says that there are 71,000 records, sensitive records, out of which 2,600 are PCI records, which are at risk uh, for this particular bucket, which contains 220 files, and the risk score is 6.29. Now, what does this mean? Like, I want to know, like, okay, how urgent is it to fix that? So the agent tells that, okay, it is totally secured, but it is a compliance exposure. It's a compliance issue. Like, if I do not oblige to it, I might be at risk of losing my PCI license over here. So I can just break down what risk it is, like where the risk is present, and what data is at risk over here exactly. So and then the agent, based on the all the complexity, by reading all the configuration which is present for that particular S3 bucket, it will recommend me what is the right action over here. So it is saying that, okay, the phase one, let's contain it, disable the cross-region replication rule, which is writing this data to this particular region, and block any new writes to the non-compliant bucket. But I can also conversate with the agent saying that, okay, no, I do not want to block the writes right away because it could impact my production rights. So once I tell agent to not block it, so it can reconfigure the plan according to my needs. So now it is recommending that, okay, enable dual writes to the target and then flip the deny in the maintenance window. And then it will also confirm with all the security configuration, with what configuration it is going to create the new bucket and this thing. So it says that, okay, current encryption is using SSE S3, which is the default encryption provided by AWS, but it is recommending to upgrade it to SSE customer managed key over here. And yeah, so I can confirm the plan, like this looks good to me. And then the agent will come up with the final plan over here. Okay. So now it will disable the replication rule on the source bucket, enable dual write, and then create a new bucket with KMS encryption, and then do the replication. And then we have to update the configuration in the application. And then in the maintenance window, we'll stop the write on that original bucket. But I can also modify the maintenance window, which I want to do on Friday evening. So I can just approve that whole request, and it will execute the all the steps one by one in auditable way. And that is where whenever any critical flow is involved, right, which is either deleting the data or making changes to a configuration, you could also have a human in the loop so that the agent is not making any disastrous changes by its own. Completes the entire remediation, and also it will not just do the remediation, as well as it will update the status in the Jira ticket, and it will log it as an evidence whenever any compliance or audit comes for that. So that's a quick demo about the agentic remediation. Now Sumit will be walking you through the entire architecture of how this agent works, and in more details over there. So over to you, Sumit.
Thanks, Harsh, and hello, everyone. So you've just seen the outcome, a finding that moves from detection to remediation without any manual intervention. One second. So for the next few minutes, I want to walk you through what happens behind the scene and explain the architecture that makes this possible. So everything is built on four core principles. First, we classify data at the device level, where the data actually resides, and that's the only place where we can capture complete context. So it's not just what the data is, but who is interacting with it and for what purpose. Second, we use a single detection engine across three critical surfaces, which is database activity, file activity, and AI access to data. So whether it's a SQL query, a RAG retrieval, an MCP call, or an autonomous agent action, so everything flows through the same in inspection layer. Third, we model behavior across four identity types: human users, AI agents, threats, and non-human identities (NHIs). So an anomaly isn't defined by a static rule. So it is defined by the gap between expected behavior and actual behavior for that specific identity. And last one, the remediation is contextual. So the agent evaluates the data, the user, the intent, and the lineage behind every event, and then generates a response tailored to that situation. So two incidents that look similar on the surface can result in completely different remediation paths based on context. So I'll walk you through each of these. So we'll start with the detection. Harsh, we can move to next slide. Yeah. So everything begins with the visibility, right? So detection has become table stakes, and the real differentiator is the quality and accuracy of what you detect, because that ultimately defines how much autonomy you can safely give to your system. So our exposure engine continuously monitors four environments: endpoints, SaaS applications, cloud infrastructure, and on-prem systems. And this is done through a single unified platform instead of using collection of disconnected tools. So two key functions happens here. So first, we have one of the component, we call it Copilot. So policy creation happens through Copilot. So our Copilot analyzes sensitive data, active alerts, system configurations, and regulatory requirements to automatically generate policies focused on reducing risk. So before introducing a new policy, it also evaluates what's already deployed. So if a similar policy exists, it inherits established severity and classification. If it is truly new, Copilot assigns its own risk tier and priority. Uh, there are compliance aligned policies as well, which we provide out of the box. So the teams, they don't have to start from scratch. Second is every exposure is identified and scored based on both severity and potential impact. And that includes misconfiguration, excessive permissions, and misplaced sensitive data, and the risky behavior from either humans or AI systems. And that risk score isn't just informational, it's the, one second. Yeah. So that risk score is uh, determines like how remediation will proceed, and we'll come to that in next section. Yeah. So once an issue is identified and scored, the next question is simple: what happens next? So this layer serves as the control plane for remediation. So it's responsible not only for ensuring issues are fixed, but for determining how those fixes should happen. So the process, it follows these five steps. So first we do context assembly. So we gather all relevant information for the findings, like the data involved, the identity behind it, the intent, and the lineage. Second is we evaluate risk. We assess blast radius, policy severity, and confidence levels for to answer critical questions like how much autonomy is appropriate for this remediation. Okay, yeah. Third is precedent matching. So if we have handled a similar event before, we inherit the established remediation pattern. If not, we evaluate it against compliance requirements and assign an appropriate tier, which we'll see. And so these tiers are like L1, L2, L3, and the fourth layer is basically the routing. So based on these tier, the finding is directed to appropriate remediation path, whether it will take L1, L2, or L3. And based on these tiers, the right agent get assigned for this remediation. And last is execution and verification. We are still on, yeah. Last is execution and verification. So the fix is applied, validated, we log it, and we record it for audit and for future precedent. So future precedent, if in future similar situation comes up, so this policy which gets generated on the fly, if it's a new one, so it gets seeded as a future precedent, so we can use it. So now with this final step is what creates the learning loop. Every approval earned once becomes our reusable knowledge, and over time the system becomes more efficient, requiring less human involvement. Now, so what we do in approve once and auto forever is we make this learning loop more tangible. So because it's central to the entire approach, the remediation lifecycle follows three stages. So observe, govern, and secure. So we continuously monitor activities, evaluate risk, and determine the appropriate action path. And then we execute remediation within controlled permissions. So the objective is simple. The loop should operate independently wherever possible. When human involvement is required, it should happen only once. And in practice, remediation policies often contains like multiple actions. So first time a high risk action is encountered, a human reviews and approves it. That approval becomes precedent. So next time, if the same thing happens, then we don't need human approval. Or if it is bound, say the configuration is such that every time if this kind of situation happens, it must go through the human approval. So that's where we define these L1, L2, L3, these tiers, right? So the key idea is that approvals are kind of investments, and it should not happen uh, recurring because every time it comes with a cost. So every approval should reduce future effort, not create like ongoing dependencies. So ultimately, the goal is fully autonomous remediation with human oversight serving as the onboarding mechanism rather than the operational model. Next slide. Yeah. So autonomy without guardrails simply creates a different kind of risk, and that's why autonomy must be bounded. The target state is that everything should be done end to end autonomously, but the level of autonomy is always comes with some risk, right? So we have defined these levels, and when we say L1, so L1 is like fully autonomous. So these are low risk, high confidence, reversible actions. So the agent executes, records the action, and notifies stakeholders. So there's nothing where we have to worry about, right? Now comes L2, which introduces human approval. So these are the scenarios which carry higher impact or low confidence. The agent recommends an action, and then human approves it, and the agent afterwards executes. There are some actions where which requires administrator approval, right? So these are like high impact or irreversible operations such as uh, like destructive changes, deletion of a bucket, or deletion of some database credentials, things like that. So where explicit administrative approval is required because uh, before agent takes those actions. So it should go through administrator approval. So these tiers directly map to the decision framework. You have already seen like autonomous execution for L1, human in the loop for L2, and administrative oversight for L3. Most importantly, security teams remain in control here. Administrators, they define autonomy levels by role, risk profile, and organizational requirements. So we can expand autonomy where trust is high and tighten controls where caution is warranted. And we can move to next slide. Yeah, so let's bring everything together and follow a single finding through the entire system. So the workflow consists of five major stages. Our Copilot, it creates and classifies policies. The exposure engine detects and scores finding across all monitored environments. And the orchestration layer assembles context, evaluates, the precedent if something of that sort has happened in past, and then routes the finding to the appropriate autonomy tier. Then we have these bounded agents, which executes remediation within their authorized permissions. And finally, verification validates the outcome, records the result, and feeds that experience back into the precedent engine. So overall, the entire workflow is administrator controlled, and which determines like how much of process can operate autonomously for different users and for different risk profiles. So if I would say if there is one takeaway from this architecture, it's this: that every component exists to answer a single question. Can the AI safely remediate the issue on its own? So whenever the answer is yes, human intervention disappears from the process. Now we can move to next slide. Yes. So what does all of this deliver in practice? Okay. Yeah. So the industry average time to contain a breach remains measured in months, right? But the across our deployed environments where we have deployed our solutions, So critical issues are remediated in approximately 4 minutes. And this is not just a lab result. So one of our customer, they reduced their Microsoft 365 remediation workflow that previously required nearly 3 months of efforts, and it has now come down to 4 minutes. So that's the kind of architecture we have built, and this is operating in a real production environment. So with that, I've covered the underlying architecture and how it translates into measurable outcomes. Over to you, Harsh. Thank you.
I think we can take questions over here. So I think there are two questions by Tapan. Starting with the first one, while it says disabling the cross-region replication rules, where is it going to deploy these rules? Yeah, so these rules are directly changed on the AWS console over there, and there is a role associated which does all these activities. So whenever there are any major changes like configuration change and all those things, so the permission to perform those changes can be given on a temporary basis, maybe for an hour or so, where these changes can be scheduled, and the agent will perform all these changes. And the second question is, if the data is not in S3 but on on-prem file servers, would you still be able to identify the data and create a remedial action? Uh,
I can take that
yes,
question.
yeah.
Yeah. So we have, like I mentioned, we have four different surfaces, and endpoint is one of them. So we have our endpoint running in our, it's like in physical laptops, our endpoint runs. And from there, everything which gets created or modified or, moved from this one endpoint to, external, outside any external host, all of this gets recorded, and this file then gets scanned for and this is happening on the endpoint itself, gets scanned for PI, PCI, or any sensitives. If there is any sensitive gets identified, we tag that file, and that tag can be, if customer they use some third party DLP, they can use their DLP to block that file to go out, or we can also take actions via our agent to take appropriate action on that.
There is a follow-up question by Tapan, like, uh, so the question is, before doing any changes, does the solution does any possible impact assessment? So yes, that is possible using the chat interface. You can ask more question with the agent in terms of understanding what could be the impact area, and wherever the agent already has a read-only access, they'll provide you the direct impact, possible impact, and wherever there could be a theoretical impact, right, which agent may not have a direct knowledge about. So it will warn you or alert you before taking those actions over there. But there has to be a combination of the agent plus the business context of that particular business needs to be there. I hope that answers your question, Tapan. Yeah.
Thank you.
Yeah. Thanks, Tapan. Any other question from any other member before we close this off? And additionally, like, would love to, if there are any further question, and if you want to get into more details of these things, mapping more use cases, so I would really love to, have a one-on-one session. You can book a demo using our website or email us, and we'll be happy to schedule a demo and take things in more detail. Thank you so much, everyone, for joining. It was a
Yeah.
pleasure walking through this.
Thank you, everyone.
Thank you, everyone. Thank you, Harsh and Sumit, for a great session. Thank you for joining.